Right, this is another problem about binomial theorem. In this case, we use this result, okay, n plus 1 ck plus 1 equals n ck plus 1 plus n ck. You can prove this by simplifying the right-hand side by using the definitions for NCR. Right, if we have this result and then we are asked to find the value of n plus 1 c1 plus n plus 2 c2, okay, up to the term n plus p cp. Now if you first look at this series, you can think whether we can say group these two terms together into one term like this, and it becomes one term. And then maybe, okay, after grouping these terms together, the results can be grouped with other terms like that. But if you look carefully, you will see that we cannot apply the given results directly, say for these two terms. Because if you look at the right hand side, okay, of these two terms, here they are having the same n here. One is nck plus 1, nck. But in this case, if you look at these two terms, this is n plus 1, this is n plus 2. And then for the coming terms, they are all different. Okay, the next term afterwards should be n plus 3 and then c3. Therefore, we cannot apply directly this result. And then how can we simplify this one if we don't know exactly how many number of terms are there? In this case, we may consider by rearranging the terms. And then we create a difference. And then if we make use of this result, say we rewrite n plus 1 c1 by applying this result, then you can compare, okay, the terms. Here is n, this is n plus 1. Therefore, if we look at the pattern, if this is n here, this is n plus 1. Therefore, if this is n plus 1, then this is n plus 2. If this is k plus 1, this is k plus 1. Therefore, for this one, it is 1, this part is 1. And then minus, okay, if this is n, this part is n. Therefore, for this one, it is n plus 1. For this term, it is also n plus 1. And then we look at the index here, k plus 1. Then for this term, it should be k. Therefore, for this one, it is 1 here. Therefore, this is 0. And then we try to do the same things for the remaining terms. Like n plus 2 c2 will be rewritten as n plus 3 c2 minus n plus 2 c1. And then we continue up to this term. And then in this case, if we add the terms, vertically, okay, this is the required sum. And then in this case, it means we add all these terms together. Then you will find that when we add the terms, we have some cancellation. n plus 2 c1 minus n plus 1 c0 plus n plus 3 c2 minus n plus 2c1. That's what it means. We can cancel these two terms. If we continue in this way, then you can see that we will cancel these two terms, and then continuously, finally, we cancel most of the terms, and then these two are left. And then the method here we are using, it is called sum of difference. Therefore, it means n plus 1c1 plus n plus 2c2 continuously up to the term n plus pcp is n plus pc1, n plus p plus 1cp, and then minus n plus 1c0. Then we can just rewrite, this one by using factorial. And then n plus 1c0 is 1. And then this is the value we require.